Separable part of separable differential equations means you can separate the variables, the x's and the y's in here. So let's see if we can do that. First of all, y prime is dy dx. Over here, both of these have nothing but y's, so they don't belong on the right-hand side. You need to divide. It's going to be dy over y minus y squared is equal to just a dx. Now that they've been separated, integrate both sides. Well, this one, how do you integrate 1 over y minus y squared? Well, notice that that can be factored. So factor out a y, and then if it could be factored, we could use partial fractions. So I think that what I'm going to do is use this right-hand side to do my algebra with partial fractions, and then I'll come back and finish the integral over here. So we'd have 1 over y times 1 minus y can be separated into something over y plus something else over 1 minus y. And then use the least common denominator, which is y times 1 minus y, multiply all three terms by it. On this side it's going to leave a 1. Here it's going to leave a times 1 minus y, and then b times y. So just pick numbers for y, like if y equals a 1, the equation would look like 1 equals a times 0 plus b times 1. So it turns out that b is equal to 1. Next, just pick another number for y, like let's say y equals 0. And this equation would then look like 1 equals a times a 1 plus a b times a 0. So it turns out that a is equal to 1. So that means our partial fractions are 1 over y and 1 over 1 minus y. So we are going to integrate 1 over y and 1 over 1 minus y. Alright, now that my algebra is done, I'm ready to integrate. So this one is going to be the natural log of y, and then plus the natural log of 1 minus y. Since the derivative of the inside is a negative 1, we need to divide by that negative 1, so this should actually be negative the natural log of 1 minus y. And on the right-hand side, we've got just an x plus c. Now we need to solve for y. Well, notice that it's 2 logarithms that are being subtracted, so we can make that 1 logarithm as long as it's going to be one big fraction with the y on top and 1 minus y on the bottom. You can then exponentiate to get rid of natural log, so we'll have y over 1 minus y is equal to, and then it's going to be e to the x plus c. And then, let's see, got a couple of things to do. We need to try and solve for y. We also need to find out what c is. So I think I'll go ahead and find out the c right now. It says if you plug in a 0 for x, you will get a 1/2 for y. So we'll have a 1/2 over 1 minus a half equals e to the 0 plus c. So 1 minus a half is a half. So we've got 1/2 over 1/2, that's 1. And this side says e to the c. So that means it's e to the 0 equals 1. So that means that c is equal to 0. Alright, so this is my function right here. I've got y over 1 minus y equals e to the x, because it turns out that c equals 0. Then, can we solve for y? Well, let's see. We could multiply both sides by 1 minus y. It's at least something to do while thinking about how to solve this. I could then distribute e to the x. Oh yes, and then those things that have y, put them on one side. Anything that doesn't have y, leave it on the other side. So this gets moved to the other side. We'll have y plus y e to the x equals e to the x. And then here we could factor out y. It would leave 1 plus the e to the x equals e to the x. And then just divide and we're done. So it turns out y is e to the x over 1 plus e to the x. And of course the good thing about differential equations is you can go back and check your answer. If you were to take the derivative here, put it on that side, take the function minus its square and put it on that side, and then prove that they're equal.